You know, for the first time in more than 50 years, humanity's in a serious, honest-to-goodness race back to the moon. But here's the thing. This isn't just a repeat of the 1960s. Not at all. The goals, the tech, even the big players, they've all changed. So the real question is, who actually has the upper hand in this new lunar race? Let's break it all down.
So the big question we're tackling today isn't just about who plants a flag first. It's really about who can build a lasting presence. And to pull that off, you need momentum. Today, we're going to deconstruct this whole 21st century lunar race to see which program is truly on the stronger path forward.
All right, here's how we'll do it. First, we need to figure out what a win even means in this new era. Then, we'll dive into the two big contenders, the super ambitious Artemis program and China's very methodical Chang. We'll also look at the biggest hurdles each of them is facing, and finally, try to paint a picture of what the moon might look like by the time this decade is over.
Okay, so before we can even ask who's ahead, we have to define the racetrack itself. Because this isn't just about one quick landing anymore. The rules for success in what we're calling the new moon rush are way more complicated this time around.
So what are we really looking at here? Well, of course, there's the big one, the timeline for putting boots on the lunar soil. But just as important are all the robotic missions, the rovers and landers that are mapping things out and testing the tech. And then you have the long game. Can they actually build something that lasts? You know, infrastructure. And finally, maybe the most important factor of all is consistency. Are they hitting their deadlines? Or are we just seeing delay after delay? This is absolutely a marathon, not a sprint.
So, with all that in mind, let's turn to our first major contender, Artemis. This is the big US-led effort. And if you had to describe it in a few words, it's ambitious, it's reliant on private companies, and it's a very high-risk, high-reward strategy.
And this quote right here just perfectly sums up the whole Artemis philosophy. This is not Apollo 2.0. NASA is intentionally tapping into this new ecosystem of private companies, like SpaceX, to build the key pieces of the puzzle. The goal is a massive leap forward in what's possible.
The plan for an Artemis landing is like an intricate ballet in space. Okay, so first, the crew launches on that absolute beast of a rocket, the SLS, tucked into their Orion capsule. But, and this is a big but, their actual ride down to the lunar surface, that's SpaceX's Starship, and it's launched separately. And this is where it gets really tricky. That Starship has to be refueled in Earth orbit by a whole fleet of tanker rockets. Once it's all gassed up, it flies to the moon to meet the crew. It's an incredibly complex chain of events, and every single link has to work perfectly.
Now, let's completely switch gears and look at a really different way of doing things. China's Chang'e program is all about a state-driven, step-by-step march to the moon.
China's approach has been incredibly deliberate. Their lunar program, the Chang'e Gengcheng, was built on a really clear three-step robotic plan. First, you orbit, then you land, then you bring samples back. And they've done all three, including being the first to ever bring back samples from the far side of the moon. Now they're building on all that proven success as they get ready for a human landing.
China's plan, on the other hand, feels a lot more like a 21st century version of Apollo. It uses two launches of their powerful new rocket, the Long March 10. One launch sends up the Lanyu lander, the other sends up the crew, or taikonauts, in their Menshou spacecraft. They meet up in lunar orbit, the crew hops over to the lander, and down they go. It's a simpler, more direct plan, but it does mean that this whole new suite of hardware, the rocket, the capsule, the lander, it all has to work perfectly the very first time.
And it's pretty wild when you put their main rockets side by side. I mean, they look remarkably similar. The American SLS and the Chinese Long March 10 are about the same height, and critically, they can launch almost the exact same amount of mass towards the moon, somewhere around 27 tons. And that payload number is everything. It's your crew, your lander, your food, your science. The real philosophical split, though, is reusability. The SLS is a one-time use rocket. It's completely expendable. The Long March 10, however, is being designed with reusability in mind for the future, which could seriously slash long-term costs.
Okay, so both programs have got these huge rockets and a plan to get to the surface, but what could go wrong? Let's get right to the heart of it. What is the single biggest bottleneck that could throw a wrench in the works for each program?
For Artemis, it really all boils down to one monumental technical hurdle, refueling Starship in orbit. I mean, we're talking about transferring hundreds of tons of super cold liquid fuel between two spacecraft in a vacuum. It's something that's never been done on this scale. It's a massive leap. For China, the risk is a bit different. It's more about execution. Can they develop and perfectly integrate three brand new human-rated systems, the rocket, the capsule,
and the lander and get it all done in time for their 2030 goal. And if you want to get a real sense of just how massive that Artemis challenge is, just look at this number, 10, or really more than 10. That's how many separate rocket launches it's going to take to fuel up just one Starship lander for one trip to the moon. The logistical complexity of that, it's just staggering to think about.
And listen, this isn't just me speculating. In late 2024, NASA's very own Safety Advisory Panel put out this pretty blunt warning. They said the lander's schedule is significantly challenged and that the landing itself could be years late. That really highlights just how ambitious and frankly how risky the entire Artemis approach is. Now, in contrast, just look at China's recent progress. Development on all the major hardware? Reportedly done. They've already had a successful flight test of their new rocket. The robotic missions that pave the way are on schedule, and the new launch site they need for the crewed missions is already under construction. When you line it all up, it paints a very clear picture of steady, measurable momentum.
So you've got one program taking this high-risk, high-reward leap, and another one making slow but steady progress. What does all this actually mean for who gets there first? Let's try to map out a realistic timeline for the rest of this decade.
2026 is shaping up to be a huge year. We've got the Artemis 2 crew scheduled to do a flyby of the moon, and in that same year, China is planning a major robotic landing near the lunar South Pole. Now, here's a really important update. Because of those lander delays, NASA is now saying the first landing will happen on the Artemis 4 mission, sometime in early 2028. All the while, China keeps plugging away with its robotic missions, building up to its own crewed landing goal by 2030.
And you know, this competition isn't just about rockets and landers. It's also about diplomacy, which is critical if you want to stay on the moon. The U.S. is out there building a huge coalition around the Artemis Accords, which are basically a set of principles for peaceful exploration. On the other side, you have China and Russia leading the International Lunar Research Station, or ILRS, which is a partnership focused on building an actual physical base and attracting other national space agencies to join in. So here's the bottom line. The United States does currently have an earlier target date for a landing, no question. But that plan depends on mastering some really difficult, never-before-done technology, and that carries a very high risk of more delays. And that stands in really sharp contrast to China's program, which is just consistently demonstrating step-by-step progress towards its later, but maybe more certain 2030 goal. So, we started this whole thing by asking who has the momentum in this new race to the moon. But as both nations shift their focus from just quick visits to actually building permanent outposts, the question itself starts to change, doesn't it? Maybe the real race isn't about who gets there first, but about whose vision and whose technology allows them to be the first to truly stay.